Welcome back, everybody. AP Chemistry, Unit 7, Section 3, taking a look at Le Chatelier's principle in intermediate and large values of K. So basically, if I was going to sum this whole thing up, what do we do? It's the elephant in the room. What do we do if we can't ignore the value of K being so large and we can't figure it out any other way? How does that math look when we have large values of K and we can't factor it out? All right, so this is the basic setup with it. Taking a look at carbonyl fluoride is a gas that's going to be forming, and we see that we've got our reaction of carbon dioxide and carbonyl fluoride and CF4 carbon tetrafluoride. We're going to make our carbonyl fluoride. We see that we have a relatively small value, so we're going to be seeing those things. And we see well, the Chatelier's principle is taking a look at the pressure of the gases. Okay, so let's take a look, and I see I have my CO2, I have my CF4, and I see my COF2. Okay, I plug in my values from what I'm given. I don't know if I'm going to run into any problems until I get to see some of these values in here. Let me get rid of this guy. And I don't know if I'm going to have any problems until I set up my ice chart. So CF4 and then COF2. All right. So seeing this, I end up in this problem. I have a 0.713. This is atmospheres now, and 0.713 atmospheres, and it's starting at 0. Okay. Now, it says that this reaction, the Kp for this reaction is 0.005. Okay, that means that I'm not going to get much product out of this, and I can plug values in and see the starting pressure and initial ending pressure of this are pretty set forward. So my initial is going to be here. My change is going to favor the product. So I'm going to be getting a negative x value, and I'm going to be gaining 2x. This looks pretty similar to what we've been doing before. Now, in the equilibrium end, I get 0.713 minus x. 0.713 minus x, and I see 2x. All right, so my Kp value we saw was 0.0050. Now, 2x squared over 713 minus x times my 0.713 minus x. Okay. Now, in the past, I showed you we could take the square root and everything and do it that way. But I want to show you something else in this case. And so the question is, can I just ignore the x's along the way? Let's do it first and see what we end up with. Okay. And that's why I'll show you Le Chatelier's principle that goes into this as well. I end up, if I derive this out, I end up with 0.0050 equals 4x squared over 0.508. In other words, at the beginning, let's see what happens if I do ignore these x's. I end up with x squared over equals 0.000635. So I go multiply both sides by this, and then I divide by my 4. That gives me an x value of 0.0252. Okay? So this 0.0252, there is something referred to as a 5% rule. Okay, the 5% rule says if x is less than 5%, then we can ignore or basically disregard that substrate, that x value. Okay, so 0.0252 divided by 0.713, that's my smallest concentration here. That gives me a 3.5%. So yes, I can cross out. This is a valid thing. I put it to the 5% rule test. So if I do that, I can cancel out those, and I found my x to be 0.252. So I simply do my math. I say 0.713 minus the 0.0252. I get a 0.688. 0.688, and then a 2x ended up being a 0.0504. Okay, that's if I could cancel it out, but I had to put it to the 5% rule test. Okay, now you see what we're building toward. We're building, and if we got intermediate or large values of K, we just don't know until we put it to the test. I haven't shown you that trick yet. Okay, let's take a look and do this again, and we're going to start to pull all these different sections together to ask some questions. All right, I've got hydrogen cyanide, and we're going to decompose it into cyanogen and hydrogen gas. Okay, and we're going to take a look and see the partial pressures. Let's see the scenario here. I have HCN, I have C2H2, and I have H2. Notice that my Kp, that's not a tiny K value. Okay, so we're going to see what happens with all of this, and let's put in our, and we want to find it at equilibrium. So let's figure out the scenario. Okay, in this case, I have a 0.45 for this one. I have a 0.32 here. I have a 0.32 here. Okay, I don't know which direction this goes, do I? I don't know if it's done, if it's headed back, or if it's going to be going back this way. So let's put it to the Q test. Okay, 0.32 to the first times 0.32 to the first over 0.45 squared. Okay, that's going to give me a value of 0.50. Now, how does that relate to my Q value? Oh, this is larger than my K value, isn't it? So I know the reaction is actually has made it over this direction, and now it's headed back. Okay, so it's gone all this way, went too far, and now it's going to head backward. I put it to the Q test. So now this tells me that I'm going to lose some of these, a certain amount, we don't know how much, and I'm going to lose or gain back to this side. Here's my initial, here's my change. Now let's find what this is once things have settled down and I'm back at equilibrium. Okay, so this ends up being a 0.45 plus my 2x, a 0.32 minus x, and a 0.32 minus x. Okay, so let's see. I have my Kp, that value is a 0.17. That's going to equal 0.32 minus x times 0.32 minus x. So it's 0.32 minus x squared over my 0.45 plus 2x squared. Do you guys remember this trick? Since this is squared and this is squared, let's take the square root of everybody and make our lives easier. So the square root of all of those things, that will give me 0.4123 will equal my 0.32 minus x over my 0.45 plus 2x. Okay, this is a value that's kind of big, so I wouldn't say that we would necessarily disregard it in this case. And in fact, we don't really need to because I can just do simple math. Let's get this by itself. Let's multiply both sides by this. So I end up in this case of a 0.1855 plus 0.8246x. That will equal 0.32 minus x. Okay, I just multiplied by both sides. Now let's combine like terms. Let's bring this guy over, and let's bring this guy over. I end up with 1.8246x equals 0.1345. So that gives me an x value of 0.0737. All right, so the pressure of my hydrogen cyanide, that's 0.45 plus my 2x. So that gives me a value of 0.5974. Okay, that's my pressure. Both of these are the same, so it's 0.32 minus my 0.037. So that gives me 0.246 atmospheres, and that gives me also for this one 0.246 atmospheres. Okay, find which direction it's going, and it looks like I didn't have anything to do with this. My K value was pretty close to significant in there, so I just kind of do that math. Okay, so I could find all of those along the way. Now, let's take a look at another example. In fact, I need to back up one, and let's take a look if we have 3 moles and 6 moles, but it's in a 3-liter container. Okay, so you see the problem here. We have to figure out our concentrations first, don't we? So we have 3 divided by my 3-liter container, so that equals 1 molar. And then I have 6 divided by 3, and that's going to give me a 2 molar. Okay, now calculate the species at equilibrium. So here's my hydrogen, here's my fluorine, and here's my hydrofluoric. Okay, we've got our starting concentrations of 1, 2, and we don't have any of the hydrofluoric at the beginning. Okay, so I see, let's see, because this is going to be a very large, I know which direction this is going to be going. Okay, we can't ignore it. And since K is so large, I know it's going to be going in this way. My Q value would actually be really small then. So I know automatically in the beginning of this that I'm going to be losing a certain amount. And each of these are ones, and this guy's going to be a 2x, isn't it? So at equilibrium, I'm going to get a 1 minus x, a 2 minus x, and then a 2x. Okay? Now, here's where it gets ugly. I have my Kc value, and that equals a whopping 115. Okay? Oh, I've seen bigger, so don't worry. We're going to see that it's 115. That's going to equal 2x squared over 1 minus x times 2 minus x. Okay? So that ends up being 115 equals 2x squared over, and if I multiply this by the FOIL method, 2 minus x minus 2x minus 3x total plus x squared. Okay? And so what if I combine all these things and get it all going, that's going to be 115 equals 4x squared over 2 minus 3x plus x squared. Okay? If I multiply both sides by this, here is my equation. If I get just 4x by itself, I end up with, let's see if I don't get lost here and everything, I get 230 minus 345x plus 115x squared, that will equal 4x squared. Okay? So combining these all together, let's get them all on one side. I'm going to subtract by 4x. I end up with 111x squared minus 345x, and let's see, that's a plus 230. Here's my A value, B value, and C value. Now remember how to do the quadratic equation. X is going to be then equal to the negative b plus or minus the square root of b squared minus 4ac all over, let's see, all over 2a. So here's my a, here's my b, here's my c. So let's plug values in, all right? I end up with a negative of, let's see, my b value is a negative 345 plus or minus the square root of negative 345 squared minus 111 times 230 all over my 2a, which is 111. Okay, so this ends up being 345 plus or minus the square root of 16,905 all over 222. Okay, that will give me two values. That'll give me 0.968, or it's going to give me a value of like 2,119. Well, if I take 2 minus that ridiculously big number, I'm going to get a negative value. Obviously, we can't get that. Okay, so if I just take a look at 9.968, I end up going 1 minus a 0.968, I end up with a 0.032. 2 minus a 1, the 0.968 gives me a 1.032, and then 2 times that gives me a 1.936. So you just use your quadratic equation, guys. I know it's cumbersome. I know it will take time. You only have 1 or 2 of these to do total, but you have to go through the process with it. Okay, now we're taking a look at another example of this. All right, I'll walk through the examples. We see we have H2, we have I2, and we have HI. Okay, so let's see, we've got pressures, and let's just plug in our values and see what we end up with. I have 0.01 here, a 0.005, and a 0.5. Which direction is this going to be going? Well, I can assume it's going to be going toward the product because this is such a large value, I'm going to get a tiny Q value. Okay, so my if I'm looking at it this way, actually, I take that back. We don't know the direction, do we? Because I have a Kc, and these are all pressures. And so we've got to figure out the direction. Now, rather than find Q, remember this equation. The Kp value is going to be a function of your equilibrium constant times your r times t, and you're going to be your delta n. Okay, so this is going to be 100 times the 0.08206, because these are pressures, times my 298, because that's got to be in Kelvin, doesn't it? Okay, and so we see, let's see, I guess I didn't include the temperature in there, but it is going to be at 23 degrees Celsius, or 25 degrees Celsius. And so I see that, then I see I have a 2 minus a 1 plus a 1. Oh, a 2 minus 2, and that's going to be to the 0 power. Okay, so that will all equal 100. Or sorry, this will give me to the 1 power. So 100 times 1 is 100. So my Q actually equals my K value. They are equal to each other. That means it is at equilibrium. So we just kind of say, and they're going to bounce back and forth a little bit. So it doesn't really matter which direction we go. This is going to go this direction and this direction. So let's get this going. And I see my initial. I see my my change, and my equilibrium is going to be a 0.01 plus x, 0.005 plus x, and my 0.5 minus 2x. Okay, my Kp value is then going to be 100. That's going to equal 0.5 minus 2x squared over 0.01 plus x times 0.005 plus x. Okay, so that's going to equal, if I plug my values in, I get 100 equals 0.25 minus 2x plus 4x squared. Kind of expand that out. This is going to equal be over 0.00005 plus 0.015 x plus x squared. Okay, so let's see from here, and again, I got that by foiling this, so I'm not losing you guys in where all that came in. All right, and so if I kind of keep going with all of this, I end up with 100x squared plus 1.5x plus 0.005. That's going to equal 0.25 minus 2x plus 4x squared. Okay, so let me bring this all the way up here so I'm not losing you guys in everything that I'm doing. If I combine like terms, I end up with a 96x squared. Actually, let me do this. Let's go 100x squared plus 1.5x plus 0.005. That's going to equal 0.25 minus 2x plus 4x squared. Now let's combine like terms. So that ends up being a 96x squared plus 3.5x minus 0.245. Here's my A, here's my B, here's my C. Okay? Negative b plus or minus the square root of b squared minus 4ac over 2a. So negative 3.5 plus or minus the square root of 3.5 squared minus 4 times 96 times negative 0.245. That's all over going to be all over 2a, so that's going to be 2 times 96. Okay, this gives me negative 3.5 plus or minus the square root of 94.2025. That's all over 192. Okay, so I take a look. My x will then be a value of either 0.03232 or it's a negative 0.0687. Well, I can't have a negative in there, so my x has got to be this. So going back to that, 0.01 plus x, okay, that will give me 0.04232. 0.005 plus x, that's going to give me 0.03732. And lastly, 2 of 0.5 minus 2x, that will end up giving me a 0.435. Okay, so I needed to figure out the direction again, and we found, oh wait, it's at equilibrium. I could actually go either way with it, and so we just kind of be bouncing back and forth to see my ending point. Okay, pretty close to what it started with, but it did change just a little bit. All right, moving on. We have a case where we have a 5-liter container. Oh, we got to remember, if it's a 5-liter container, we got to find our strengths. Okay, and we also have grams of that. So we've got some math to do on the side. Let's take my 15.7 grams of hydrogen. We got to convert that to moles of hydrogen first. Okay, so that's we'll just call it 2 grams per mole. And so I end up with 7.85 moles of hydrogen, and that's over 5 liters. So my strength of my hydrogen is a 1.57 molar. Okay, now we have 295 grams of iodine. Okay, so 295 grams of iodine, and I see that I have 254 grams of iodine because it's diatomic, 1 mole. And so I end up with 1.157 moles of iodine in 5 liters. And so my strength of my iodine is a 0.231 molar. Okay. Now, I see that also my K value is quite large. Okay, so I can't cancel that out. But let's put it to the test to kind of see. And why we're doing this is it's a little bit different. I see that my hydrogen is first going to go here, and my iodine, and then my hydrogen iodine. All right, so the initial, I'm going to go through and say 1.57, 0.231, and 0. Now, my change is going to end up going and subtracting by the smallest, so 0.231 in this case, 0.231. Notice I didn't use it all up though, did I? And so I'm going to gain 2 times that because the 2 here, so that ends up gaining a 0.462. So I've used up all my iodine, but I didn't use up all my hydrogen. So at the end of this, I end up with 1.339, a 0, and a 0.462. But guess what, guys? I'm not done because I have 0 here, but I got a lot over here. It's going to now go the other way. So here's what I do. I take a look at it and I say, as it's going this direction, these are my values. But now it's going to bounce back because I used up all of this, and let's see what happens here. Okay, so I have my initial changes and my initial equilibrium values. Now let's go the other direction, and I'm going to lose some of this, but I don't know how much. So that's going to be a minus 2x. And this guy's going to gain a certain amount out of it to get some back, and this guy's going to gain some of it as well. So I have a new change, okay? Because we're going back this direction, okay? And so I end up at equilibrium. Now that it's bounced back, I get a 1.339 plus x. I get a x, because this was 0 to begin with, and a 0.462 minus 2x. Okay, so in taking a look at this, I end up with 701 equals 0.462 minus 2x squared over 1.339 plus x times my x. And so what do I get? I get a 1.339x plus x squared, okay? Now, since this is going to be above 500, it's a very large K, let's plug in our values, and let's just play the game. What would happen if I did cancel out my x's, okay? And so if I did cancel out my x's in here, I would end up with 701 equals, and if I just combine like terms, I end up with 938.639x. Okay, there's my x. And that will equal 0.213444. X would equal 2.3 times 10 to the negative 4. Okay? Now, remember the rule. Do we have a 5% rule? Am I going to be lucky and that I end up with a 2.3 times 10 to the negative 4? Is that greater than 5%? Well, this ends up being less than 5%, so yes, I can cancel. Whew, that's nice. It's an intermediate value. It is large enough to cancel, and so I just take a look and I say my 0.339 plus x, well, that's going to equal 1.339. My x, okay, that ends up being my 2.3 times 10 to the negative 4, isn't it? 2.3 times 10 to the negative 4. Okay? And then my last one is 2.62 minus the 2x, and so I end up with a 0.4615. Okay? I doubled it. Now, you could get by with 0.46 if I did it that way, but since I get doubling that, I could factor it in. So I can, in this case, get by with just canceling out those x's because it hit that 5% rule. All right. Now, at a particular temperature, okay, the equilibrium constant for this ends up being 5,000. Okay, so I need to, in this case, write out my equation. I end up with CO plus my O2. That's going to equal, at equilibrium, CO2. So if I balance this out, I end up having to have 2 of these and 2 of these. Okay, in this problem, they tell me that I have 5 liters per mole, so that's going to be my constant. Okay, so my Kc is 5,000. And we want to find the equilibrium at all of those if we've got 2 in a 5-liter container. So 2 moles in 5 liters, that's going to equal 0.4 molar of everything. Okay, so if it's going in that direction, I get 4 molar. Okay, all right, so let's see what's going to go on. I see at the beginning, I have 0.4 here, I have 0.4 here, and we're starting with none in the bucket. All right, so obviously if it's none in the bucket, we're going to go this direction first. So I'm going to subtract x, or I'm going to subtract. We know how much it's going to do. It's going to lose that much first. Okay, that's going to lose, oh, I should mention, notice this is going to be doubled here, isn't it? So if I double that, I'm going to end up with 0.4 doubled, and so I end up with a negative 0.2 in this case, because it's half of that. Okay, and this is going to gain double. Okay, so 0.4. Okay, that's my initial. Or sorry, that's my change. Now, I take a look, and since we're going in this direction, at equilibrium then, this will be gone, and I get a 0.2 left over and a 0.4. So when we're doing this, we're saying let's use up something. We got double of everything, okay? So if I do that, then let's go back the other way, okay, and see what we get. Well, now, if I'm going back the other way, we just don't know how much we're going to be losing back to the reactant side. Notice this is 2, so I'm going to lose 2x. This is going to be 1, so he gains just 1 of those. He's got 2, so he'll gain 2x. Okay, so we end up with, at the end of all of this, okay, we end up with, this is my second change, at equilibrium, I end up with 2x. I end up with 0.2 plus x, and this is going to be 0.4 minus 2x. Okay, so when I'm at 5,000, that will equal 0.4 minus 2x squared over my 2x squared times 0.2 plus x. Okay, if I do all of this, and if I got rid of just these x's again, okay, we're just going to play that game. If I can do that, let's see if I can play my 5% rule. I'm going to end up with 5,000 is going to be 0.16 over 0.8x squared. That equals 5,000. And so if I multiply both sides by 0.8x squared, I'm going to end up with 4,000x squared equals 0.16. X squared will then be 4 times 10 to the negative 5, and x is 0.00632. Can I get away with actually canceling out my x's? Well, this is going to be less than 5%, and so yeah, I can do that. I can disregard, and so my My carbon dioxide is just 2x. So what did that end up being? X was 0.00632, and so that's 2x, so I get 0.0126. This is zero point 0.2 plus x, so that's a 0.206x. And this is zero point 0.4 minus 2x, that's a 0.387. Okay, since I could disregard the x's in my change, then I can go ahead and do that step. All right, this is the last problem, guys. This has been a long one. All right, seeing we have basically we could summarize this because we've got some spectator ions. We could refer to this as my iron 3 nitrate. And this would be my KSCN. But we can actually abbreviate this a little bit just because of the spectator ions. Okay, clean it up so we're not writing so much. So I have iron 3, I have my SCN, and I have my FeSCN. My Kc value is 1,111. Or 1,100. So this is a very large. We know the reaction is going to be going this way to begin with, at least. Okay, so let's plug in my values. Okay, we have the liters and we have the molar, and we're good to go with everything in here. This ends up being a 0.10. This ends up being a 2.0, and there's nothing in the bucket to start with. Now, let's start it this way. Because my K was large, let's start it going in this direction. My first change is going to be the subtracting off the smallest value. Okay, this is minus 0.10, and this is gaining the 0.10. So at the first equilibrium, that when it's going to the product side, I end up with 0 here, 1.9 here, and this is a 0.10. Now, we went a little bit too far. Now we're going to bring it back the other way. And so my second change is going to be coming off a certain amount. We're going to be gaining one of those, and we're going to be gaining one of these. Okay, it's a 1-to-1-to-1 reaction. And so at the second equilibrium, now let's bounce back. You'll notice that I'll have an x here. I'll have a 1.9 plus x here, and this is a 0.10 minus x on this side. And so my Kc value, that will equal 0.10 minus x to the first power over my x to the first power times 1.9 plus x to the first power. Okay, that will give me 1100 equals 0.10 minus x over 1.9x plus x squared. That gives me 0.10 minus x equals 2090 x plus 1100 x squared. So if I was going to combine all the like terms, 1100 x squared plus 2091 minus 0.10. Here's my A, here's my B, here's my C. This is one I just can't ignore. It's above the 5% rule. It's just too large because it's above 500. So negative 2091 plus or minus the square root of 2091 squared minus 4 times my 1100 times negative 0.10 all over 2 times 1100. So I end up with negative 2091 plus or minus 4372281 minus 4 times negative 110 all over 2200. And so if I was going to clean it all up, I end up with, let's see here. This ends up being negative 2091 plus or minus 437,000, 4 million. These are large numbers, guys. 2281 minus, well, let's just do it this way. 2091 plus or minus 2091.1054 over 220. So x would then be equal to 4.8 times 10 to the negative 4, or a negative 19. Can't have a negative, so here's my x value. So if I plug that all in, all the fun stuff, hopefully you skip through a lot of that fun part. 4.8 times 10 to the negative fourth. I end up with 1.9 plus that ridiculously small number, 1.5, and zero point 0.1 minus that and ridiculously small number ends up being 1.10. Okay, I had to calculate it out to find what this is, otherwise we could have just ignored it from there. Good job, guys. That was a lot of work to go through. Thanks for sticking with it. And basically from there, you're going to see a couple of these along the way, and you should be good to go. All right, good luck.